Hello everyone, welcome back. In this lecture, we are going to solve this problem. Again, it is from developments. So in this problem, we have a right cone. Right cone means the central axis should be the central axis or the axial height of this cone is at 90 degree with the base radius. It is a cone, so it should be at a circle at the base. So the right cone of 55 mm diameter of base and 75 mm height stands on its base on HP. It is truncated at an inclined surface of 45 degree to the axis. So the inclined surface is 45 degree to the axis and lying at a distance of 40 mm from the apex. Apex is the top point of this right angled cone. The top point from the apex is the top point. So from the top point, the surface, the truncated surface is at a distance of 40 mm. It means the truncation plane is passing through at a distance of 40 mm from the top point or apex of the cone. Now draw the development of the lateral or the truncated face of the cone. Now just back to the question. We have a diameter of base. So if a right angled cone is resting on HV, then we will have in top view we will have a circle as well as the slant edges, uh, whatever we use to represent here. So in a right angle cone which is of 55 mm diameter, so just going to mark it here, diameter is 55. Just change it to the main drawing now. So in the top you will have this one. Again we will have a top point here, but here what I'm gonna do, if we have a circular profile, then to trace it very precisely, what we do, we divide this circular part into minimum 8 equal parts. 8 equal parts are good enough to trace this curve profile. So just I'm going to first divide this circle into 8 equal parts. Just change this to the main drawing. And now, okay, in 3D you can assume like this. Suppose we have a circle here. Okay, instead of a circle we can use a like this. And okay, instead of this, what we will do to understand is this thing. Okay, so from here, suppose the side is 55 mm and these are some points. Okay, so this is a right angled cone. So here, if it is resting on HP, then in the HP we will have a the circle, which is 50 mm, 55 mm here, diameter of the circle, and you can see this top point will be there, and as well as these slant edges. I've used here only 3 slant edges. So here, instead of these 3 edges, I'm going to divide this circle into 8 equal parts. So then we will have 8 equal slant edges. So just going to divide this thing with polar array command. Array polar, provide the center. Now by default it is dividing this circle into 6 parts. Now go to the items here. This one is item right next to the base point. Select this one. Here you can see by default it is 6. So it is dividing this into 6 parts. Change it to 8. I need 8 equal parts. The center. So now our circle is divided into 8 equal parts. It means like the slant edges, there are 8 slant edges. Additional to these 3, there are 5 more slant edges which are equally spaced in the circumference. So I'm going to mark these slant edges. So here, instead of alphabets, I'm going to use numerals just for There's no reason to use this. Just here, just want to use this. That is why I'm using this. There's no special reason behind this. You can use alphabets or any other special characters if you want to use. So I've divided this circle into 8 equal parts, or you can say I've divided this right angled cone into 8 equal parts. So we will have 8 equal portions of this curve structures. Right now we have 3 curve structures. First is from here to here, second is from here to here, third is from here to here. So but here instead of 3 I have divided into 8 equal parts. Now again I have to draw. We need to draw the front view from this top view. This is our top view. So here, say the height of this angled cone is 75 mm. So create a vertical line 75 mm long. Now you have to use this construction lines. One will be individually available on the reference line. This 2 in front view, 2 and 8 will be on the same vertical line. You can see this line is passing through 2 as well as 8. So 2 and 8 will be on the same vertical line. Now 3 and 7 will be on the same vertical line. Similarly, 4 and 6 will be on the same line, or you can say on the same point. 5 will be individually available here. Either you can write it here. This one is 1 dash. This one represent 8 and 2 dash, 8 dash and 2 dash. This point represent 7 and 3 dash, 7 dash as well as 3 dash. This one 6 dash and 4 dash, and this point on the right side is 5 dash. So now we need to connect these slant edges to the apex of the cone. Apex is the top point. So these are, and from here and up to this point, again from here to here. Now just going to change these slant edges to the main drawing. So this is our front view of the right angle cone, of which this is the height, which is of 75 mm. Okay, so it is 75. Now, so this is our position. Now we need to place the truncation plane. It is truncated. This cone is truncated at an inclined. It is truncated at an inclined surface of 45 degree to the axis. So after truncation, the truncated surface, the truncated plane is placed like this, and after truncation, the plane truncated surface of this cone is at an angle of 45 degree to the axis. So this is our central axis or axial height. So the truncation of this plane, this cone, is such that after truncation the surface, or you can say the truncation plane, should be at an angle of 45 degree to the axis, lying at a distance of 40 mm from the apex. So from this apex top point you have to measure a distance of 40 mm. So I will create a line. I'm going to create an offset at a distance of 40 mm. So this is, so from the top or from the apex, this is 40 mm distance. So the plane is passing through this, and it should be an angle of 45 degree. If the plane is at angle of 45 degree to the axis, it means to the HP it is also 45 degree. So just make it 45 degree. Now either if you measure this one, if this is 45, then again this one will be, again this will be 45, because total is 90. So just mark this one, from extend this from here to here. Now just going to remove this one. Okay, I can see, check whether it is passing through the point which is at a distance of 40 mm or not. Just check this thing. Okay, so this thing is passing through a point which is 40 mm from the apex or from the top point. Now change it to the main drawing. Now this is the truncation plane, or you can say after truncation this is the truncated surface of the angled cone, and as per the condition this angle, or you can say this truncated surface, should be at 45 degree with the axis. So it is at 45 degree with the axis. Okay, so now what I need to do is I need to truncate this, and instead of this thing I'm going to use construction line to show that this cone has been truncated. So now this blue region shows that this plane has been, this body has been truncated. So, okay, from here we'll have solid line. So this is going to become main drawing or solid. So this is the truncated part, and this is the leftover part after truncation, and the truncated surface, and the line, the truncated surface should pass through from the axis, pass through the axis at a distance of 40 mm from the apex, and this truncated surface should be at an angle of 45 degrees with the axis. So these are the conditions for the truncation. Now we have to measure the now we have to find out the lateral surface of this right angled cone after truncation. So initially, you know, if you open this thing from this point A, then we will have a profile like this one. The initial lateral surface, or the lateral surface of this right angle cone without truncation, will be like this. Okay, it will be somewhat like this. If you open this thing from this point 1, the lateral surface of this right angle cone will be like this. Here we have divided into 8 equal parts, so we will divide this thing into 8 equal parts. But this will be our lateral surface without truncation, and from this lateral surface we have to find out this truncated part, lateral surface of this truncated part. So what we will do is, so here you can see the placement. You know this thing again, these two edges, this one, these two corners, point 1, all 8 points are on the circumference, and this is a height. So you know this base point and this O, the center, suppose this is, this apex is represented by O dash. So here we will use O. This is the top point or apex of the cone. So now this 1 and O are on the same vertical line. If you go back to the previous question, as of the square in a square pyramid, this point 1 and this O are on the same horizontal line. So this here, this line 1O, and so this length H is represented by this 1 dash O dash. So this one, this left extreme line, represent the actual length of this line dash. This line dash 10, 1O is the actual length of this 10 is in the this front view. Similarly, this 5O and this 5 dash O dash. So this length is the actual length of this length dash 5O, because both these points, 5 will be at the base and O will be at the top apex, and both points are on the same horizontal line. That is why we will get the actual length of this length dash on the extreme right and extreme left. So this one 5 dash 0 dash 79.9, and again this 1 dash and 0 dash 79.9 again. Both these slant edges represent the actual length of this slant edge. But here you can see 876 are also on the circumference, and 234 are on the circumference. But you can see the stop point O and this 2 are not on the same horizontal line. That is why this line 2O in the front view, this is 2 dash O dash. So this is not the actual length. So like the previous question or like the square pyramid one, what we will do, we will measure these 2O, 3O, 4O and 6O, 7O, 8O from here to here. These three lines represent this 3 points and this 3 point. So these three will be measured. These segments are not the actual length of these 3 and this 3 6 slant edges. So we will measure this one, and this 2 8 3 7 4 6. We will measure these segments in terms of these lines. This either this 5 dash O dash or this 1 dash O dash, because these two represent the actual length of the slant edges. So either you can measure it in terms of this left line or in terms of this right line. Both are correct. So what I'm gonna do, we will measure this segment. This is the actual dimension. This is because this 1 dash O dash represent the actual length of the slant edge, because they are on the same horizontal line, but they are not on. But this 2 3 4 are not on the same horizontal line with the O. So these are not correct. So this one is the actual length and this one is the actual length, but these three are not the actual. So to measure this, we will use these, either this one or this one. So measure this in terms of, so what I'm gonna do here is I'm going to measure these two in terms of this right one and this third